Hi, I just noticed I had a comment on one of the videos that I've uploaded, and I had a request for A11, I believe. So I'm going to go ahead and go to the Algebra 1, A11, and here it is. Let's go to A11, and it's about classifying numbers, and I'm going to see if I can answer some of these. And is 0 a real number? Well, we've heard of it before. And any number that you know, that you've ever heard of is a real number. The only ones that aren't are called complex numbers and sometimes imaginary numbers. So yes, 0 is a real number. And in fact, it's one of the most important numbers we've ever had in history. Now, which of the following describe 10? Select all that apply. Well, 10 is a whole number. Whole numbers start at 0, 1, 2, 3, and so on. It's a rational number. And the reason it's rational, and we can actually prove it's rational by putting 10 right on the screen here, 10 over 1 proves that it's rational. Any rational number can be written as a ratio. And there it is, 10 over 1. Whole numbers start at 0, 1, 2, 3, and so on. It is a real number because you've heard of it before. And it's also a natural number. Natural numbers are the numbers we count with, like 1, 2, 3, 4. I think of natural numbers as being like caveman numbers. That's 1, 2, 3, 4. And a lot of people say, well, wait a minute, aren't those the whole numbers? Well, the whole number only includes one extra number, 0. And that doesn't seem like a big deal, but 0 was a really big deal in history. We weren't able to have positional place value numbers until 0, until we had a symbol for 0. So it was a really important advancement. So all of these things describe 10. Sorry it took so long. There it is. Submit 30. Let's see, what do we have next? Which of the following is a natural number? So think caveman or think 2-year-old. Which one of these will a 2-year-old be able to count to? And that would be 2. Which of the following are natural numbers? These are the numbers we count with, 5 and 6. Go. Is pi an integer? Well, of course not. Pi is approximately 3.14159, and it keeps going forever and ever and ever. It is called an irrational number, but pi itself is actually the number of diameters around a circle. Let's see, what do I mean? There's a circle, that's supposed to be a circle. Here's a diameter, that's supposed to be a diameter. And if I count the number of diameters around any circle, there's 1 diameter, here's 2 diameters, here's 3 diameters, and then I've got a little bit, like a 14% left over. This number of diameters is right there, and that's pi. And of course, pi is not an integer, no. Which of the following describe 8.444 repeating? Now, a lot of people get confused about these. Now, I'm going to prove that it's a rational number. Now, some people think of irrational numbers as being decimals that go forever, but that's not true. Irrational numbers never repeat. This is a repeating decimal. Now, one way to always write repeating decimals is to put them over 9s. So this is 4 over 9. 8 and 4/9 is the same as 8.444 repeating. Now, if I want to change this mixed number into a rational number, or rather a ratio, I multiply the 8 times 9, which is 72, and 4 more makes 76 over 9. This ratio is the same as this mixed number, and of course it's the same as that repeating decimal. Another way to write repeating decimals is to write 8.4 and then put the bar over the 4. Not the 8, just the 4. So this is a rational number. There's my proof that it's a ratio. It, of course, is a real number. Remember, all numbers are real except for the complex, and you won't be learning those until the end of the course, so don't worry about those. And it's not an integer because it's not a counting number or its opposite. So there we have it. Which of the following is an integer? Well, integers are whole numbers and their opposites. This one, 8, is the whole number, or the integer in that case. Which of the following are natural numbers? Remember, natural numbers are the ones that babies count with. 1 and 3. I don't think babies are going to be counting in backwards into the negatives. So, and cavemen too. These are literally 1, 2, 3, all of our cavemen numbers. Which of the following is an integer? Well, it happens that 0 is an integer. It's a whole number, it's a natural number, it's a real number, it's all those things. It's an integer. Which of the following describes a negative 85? Well, let's prove that it's a rational number. Negative 85 over 1. There, it's a ratio, so it's a rational number. It's not a whole number, because whole numbers, remember, start with the whole. 0, 1, 2, 3, and so on. It is an integer, though, because it is the opposite of whole number. Is the square root of 58 a rational number? Now, if the square root is a perfect square, like 9, then 3 is a rational number. All other square roots that don't work out like this, like 16, square root of 16 is 4. The square root of 25 is 5. All the numbers in between, the square root of 36 is 6. The square root of 49 is 7. And the square root of 64 is 8. This number is, square root of 58 is in between these two. It's between 7 and 8. It's pretty close to the middle. We can see that it's 6 away from 64, and it's 9 away from 49. So it's a little closer to 64. So I might say 7.5, 7.6, probably closer to 7.6. But it is an irrational number. So it's going to be 7 point, maybe 6. But this decimal is going to go forever. All radicals that you cannot reduce are irrational numbers. Be careful though, sometimes you'll have this situation. For example, let's say 20.25. This happens to be 4.5. And sometimes you're going to run into one of these situations. But for whole numbers, if you take a radical and it's not a perfect square, it is irrational. So this is a no. Which of the following are integers? We've got a negative 47, and that is it. I'll go a little faster. Sorry, it's taking so long. Which of the following is a rational number? Well, rational numbers, remember, are repeating decimals can be a rational number. To prove it, this one's a lot tougher to see. It's only the 6 that gets repeated. So this is 66 plus 4/10. But then we've got the 6 over 90. I could get into the explanation of how I know that, but if I added this together, this one is going to be times 9, so it's going to be 66 and 42/99. And that can be reduced. That's divisible by 3. I've got 66 and 42 divided by 3 is 14 over 33. And I could make this into a ratio, but it's kind of long. But there it is. Sorry, Got a little bit too loud. All right, there we go. 6.284, that is 6 and 284 thousandths. That's how we read decimals. This is the fours in the thousandths place. Another way to write these, which is really nice, whenever you see a decimal, you can write the number that you see, 6284, over the last place, which is the thousandths place. For example, if I said 65.43, then I could write 6543 over 100. It's just a way to write these as ratios. And a real number is any number that's not complex. And of course, it's not only is it real, it's also rational. So yes. Which of the following describe 2.51 repeating? So again, that's 2 and 51/99ths. And if you wanted to simplify this to a ratio, it would be 2 times 99 is 198. And if I add that to 51, I get 249 over 99. So there's my ratio. It is a rational number, and that's it. Which of the following is a natural number? We can count to 10. Is not, no, it's not. It's rational, but it's not an integer. Which of the following are natural numbers? Now this one's kind of funky looking, but this is supposed to be the square root of 1, which of course is 1, because 1 times 1 is 1. This happens to be equal to 1, and this one is also equal to 1. So even though they're written a little bit different, this one is also 6 over 3, which is 2. Since this can be written as 2, this can be written as 1, this one can be written as 1, these are all literally natural numbers, even though they're not written in that form. Which of the following is an integer? That would be 8 over 1. The square root of 0.48 is not, neither is pi, or even the absolute value of pi, doesn't matter. 8 over 1 is 8, which is an integer. Sorry, it's taking so long. I shouldn't have went into so much detail. Is it rational? Yes, repeating decimals are rational. To prove it, again, 6 and 53/99, which of course is a mixed number. And if we wanted to change it, we could. I'm not going to do that. So yes, it's rational. The square root of 0 is 0. It is not a natural number. Be careful. Natural numbers always start with 1. It's a whole number. And of course, it's a real number. Come on, go. Which of the following are integers? This is 9 divided by 9 is 1. And when you take the square root, you get 1. And that is it. Just that one. Is 7 a rational number? Of course. 7 over 1 is a ratio. Which of the following are integers? 9 and 6 are both integers. Be careful. Every once in a while, they'll write some kind of weird one that can be reduced. This can be reduced to negative 1.5 or negative 1.5 or negative 3/2, but that only makes it a rational number, not an integer. Which of the following describe pi? Irrational. It is an irrational number. It's none of those other things. Oh, it's a real number. Sorry. There we go. Remember, all numbers except complex, which would be things like 2 plus I, or imaginary, like I, 2I, 7I, and so on. Complex are real plus imaginary. Imaginary are just multiplying by the I. So real numbers are any number, including pi. Which of the following is an irrational? The square root of 1 is 1. The square root of 8 can be reduced, but it is an irrational number. It just happens that it is between the square root of 4 and the square root of 9. The square root of 4 is 2, the square root of 9 is 3, and the square root of 8 is between 2 and 3. It's a lot closer to 9, so it's going to be about 2.8 or 2.9, but it's going to be a decimal, and it's never going to end and never going to repeat. So this it's not going to repeat forever anyway. The square root of 8 is irrational. I was looking for some more. Square root of 5 is irrational. No. And it looks like I have one more. Which of the following are whole numbers? Well, this is the absolute value of 6 divided by 3, which is 2, and that happens to be positive 2. The absolute value just always makes it positive. Now this one happens to be rational, maybe, but no, it's not. It's neither one, actually. The only one is the first one. That's the only one that's a whole number. And it looks like we're all done. Hopefully you're able to classify some numbers now. Sorry it was such a long process on my part, but I always enjoy going into the details. So hope you got it. Good luck on that. I will end my recording and I'll upload it for you. Meeting for all, come on, and